And now in this lecture we'll find out the radius of a circle. In the drawing we have a circle. Inside this circle we have chord DB is equals to 2 units in its length. Chord AC equals to the square root of 2 units in its length. In addition we have this is angle BED. The size of this angle BED is 45 degrees. Again, our mission is to find out the radius of this circle. So first of all, we will join points A and D together by a straight line. By joining points A and D, we create here peripheral angle ADC. This is peripheral angle ADC. Peripheral angle ADC. We define the side of this peripheral angle ADC as y over 2. So peripheral angle ADC equals to y over 2 degrees in its size. This peripheral angle ADC is subtended on chord AC. Again, peripheral angle ADC is subtended on chord AC. In the next step, we define the center of this circle. This point is point O. And we will join points O and C together by a straight line. We will also join points O and A together by a straight line. By doing this construction, we create here the central angle AOC. This is the central angle AOC, and this central angle AOC is subtended on the same chord AC, exactly like this peripheral angle ADC that is also subtended on this chord AC. So in the next step, we will implement rule 13 in our drawing. So I'll repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have inside this circle, this is peripheral angle ACB. Peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Again, peripheral angle ACB is subtended on chord AB. In addition, we have here central angle AOB. This is central angle AOB, and this central angle AOB is also subtended on the same chord AB. And according to this rule 15, the size of this central angle AOB must be twice as large as the size of this peripheral angle ACB. Why? Because of the fact that both of those two angles they subtend on the same chord AB. We know that the size of this peripheral angle ACB is theta, and therefore the size of this peripheral angle AOB must be equal to 2 theta. Okay, so according to rule 13, the size of peripheral angle that is subtended on the same chord, the size of the central angle that is subtended on the same chord as a peripheral angle, the size of the central angle is twice as large as the size of the peripheral angle that is subtended on the same chord. Okay, so we can implement rule 13 in our drawing. Why? Because in our drawing those those two angles, they are both subtend on chord AC. And the side of this peripheral angle ADC, the size of this peripheral angle ADC is y over 2, and therefore the size of this central angle AOC that is subtended on the same chord called AC must be equal to y over 2 times 2. Y over 2 times 2 is y. So the size of this central angle AOC is y degrees. So I'll write it down. Likewise, we will define peripheral angle BAD. This is peripheral angle BAD. We define the size of this peripheral angle BAD, this angle, as x over 2. So this is peripheral angle BAD, and this peripheral angle BAD is subtended on chord DB. In the next step, we'll join points O and B together by a straight line. And we will also join points O and D together by a straight line. By doing this construction, we're going to do central angle DOB. This is central angle DOB, and this central angle DOB is subtended on chord DB, exactly like this peripheral angle DAB that is also subtended on the same chord called DB. So those two angles are both subtended on the same chord called DB. And therefore, according to rule 13, the size of this central angle must be twice as large as the size of this peripheral angle, because both of them, they subtend on chord DB. The size of this peripheral angle DAB is x over 2, and therefore the size of this central angle must be equal to x over 2 times 2, that is x. According to rule 13, of course. In the next step, I'll copy the green triangle ADE in a new page, and we will implement rule 4 on this green triangle AED. So actually, this is triangle AED that I copied from the original drawing. This is angle EDA. The size of this angle EDA is y over 2, and the size of this angle EAD is x over 2. Those two angles are both defined as the interior angles of this triangle, triangle AED. So I write it down. Those two angles are defined as the interior angles of this triangle AED. And this is angle AED that is also defined as the interior angle of this triangle AED. So those three angles, they are all defined as the interior angles of triangle AED, while this is angle BED, that is equals to 45 degrees in size, and this angle BED is defined as the exterior angle of this triangle AED, while because of the fact that this angle BED is located outside triangle AED. So this angle is an exterior angle of this triangle AED. So in conclusion, we have here three interior angles, x over 2, y over 2, and this angle DEA, and this is angle BED, that is exterior angle of this triangle ADE. So in the next step, I will present to you rule 4, and we will implement rule 4 in our drawing, in this triangle ADE. So according to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have this triangle. Inside this triangle we have angles A, B, and C, and those three angles are defined as the interior angles of this triangle this triangle, and this is angle E, that is outside of this triangle ABC, and this triangle without a name. So angle E is located outside of this triangle, and therefore this angle E is defined as an exterior angle of this triangle. And according to rule 4, the size of this exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. So here we have three interior angles of this triangle, A, B, and C. This is angle C, that is an interior angle that is adjacent to angle E. And the two other angles that are not adjacent to angle E are A and B. And according to this rule 4, the size of this angle E equals to the sum of the two interior angles that are not adjacent to it. That is to say, angle E equals to A plus B, because A and B are the two interior angles that are not adjacent to angle E. So in conclusion, we can find out that the size of this exterior angle E is equals to A plus B, that is the sum of the two interior angles that are not adjacent to this angle E. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have, this is triangle EDA, and those three angles, they are all defined as the interior angles of this triangle EDE, and this is angle BED, that is defined as an exterior angle of this triangle EDA. According to rule 4, the size of this exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA, that is adjacent to this angle BED. And the two other interior angles that are not adjacent to it are those two angles, y over 2 and x over 2. And the sum of those two interior angles is y over 2 plus x over 2. And according to rule 4, the size of angle BED is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is equal to x plus 2 plus y over 2. So I write it down. So according to rule 4, we actually found out that the size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is equal to x over 2 plus y over 2. but it is given as a question that the external angle BED of triangle ADE is equals to 45 degrees. So we can substitute angle BED by 45 degrees. So angle BED equals to 45 degrees, and it is equal to x over 2 plus y over 2. So here we will multiply this equation by 2, and we'll get that 45 degrees times 2 is 90 degrees, and it is equals to x over 2 times 2 is x, plus y over 2 times 2 is y. So in conclusion, we actually found out that x plus y equals to 90 degrees. So here we'll subtract x from this equation, and finally we get that y equals to 90 degrees minus x. In the next step, I repeat quickly on the law of cosines, and we will implement the law of cosines on those two triangles, triangle BOD and this triangle COA. So, according to the law of cosines, first of all, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. The side of side AB is A, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC. The size of angle BAC is theta. So in this triangle ABC that could be any triangle, the following equation is true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can actually implement the law of cosines in any triangle. So in the first step, I'll copy this triangle BOD in a new page, and we will implement the law of cosines in this triangle BOD. But before that, we'll find out what is the definition of line segment OB. Point O is the center of the circle. Point B is the point on the circle itself. Therefore, OB is the radius of this circle. That is the radius that we are looking for in this question. We will define the radius of this circle as R. So OB equals to R. OD equals to R. OC also equals to R. And OA also equals to R. All those 4 line segments are the radii of this circle. Therefore, each of them is equals to R. So in the next step, I'll copy this triangle BOD in a new page, and we'll implement the law of cosines in this triangle BOD. Side DB equals to 2 units in its length, according to what is given as the question. Side OB equals to R, and side OD also equals to R. They are both the radii of the circle. That is equals to R. So actually, this is triangle OBD that is copied from the original drawing. The next step, we will implement the law of cosines in this triangle OBD. So according to the law of cosines in this triangle OBD, cosine x equals to OD square. OD is R, therefore OD square is R square plus OB square. OB is also R, therefore OB square is R square, so it is plus R square minus DB square. DB equals to 2, therefore DB square is 2 square, that is 4, so it is minus 4 divided by 2 times OD, OD is R, times OB, OB is also R. So in conclusion, we found out that cosine x according to equation 1 equals to R square plus R square, so R square plus R square is 2R square minus 4. So in total, in the numerator we have 2R square minus 4 divided by 2 times R, that is 2R square. So here we have 2R square minus 2R square is 1, and we also have here minus 4 over 2R square. So cosine x according to equation 1 equals to 1, and here we'll divide both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R square over 2 is R square. So in conclusion, we found out that according to equation 1, cosine x equals to 1 minus 2R square. Okay, so in the next step, I copy this triangle COA in the new page, and we will implement the law of cosines in this triangle COA. Side AC equals to the square root of 2 units in its length. Side AO equals to R, and side OC also equals to R. Angle AOC, the size of angle AOC is y degrees. So actually, this is triangle AOC that I copied from the original drawing. In the next step, we will implement the law of cosines in this triangle AOC. According to the law of cosines in this triangle AOC, cosine y equals to AO square. AO is R, therefore AO square is R square plus CO squared. CO is also R, therefore CO squared is R squared. So it is plus R squared minus AC squared. AC is square root of 2, therefore AC squared is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times AO is R, times CO is also R. So if we found out that R squared plus R squared is 2R squared, so in total, the numerator of this expression we have 2R squared minus 2 divided by 2 times R, that is 2R squared. So cosine y equals to 2R squared over 2R squared is 1. And we have also here minus 2 over 2R squared. So cosine y equals to 1. And we have here, we divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1. And 2R squared over 2 is R squared. So in conclusion, we found out that according to equation 2, cosine y equals to 1 minus 1 over R squared. But we've already found out that y equals to 90 degrees minus x. So y equals to 90 degrees minus x. And therefore, we can substitute y in this equation 2, by 90 degrees minus x. We will do it now, and we will get that according to this equation 2, we have cosine y, and y is 90 degrees minus x, so it is cosine 90 degrees minus x is equals to 1 minus 1 over R squared. So in conclusion, according to equation 2, we actually found out that cosine 90 degrees minus x equals to 1 minus 1 over R squared. So here we use the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. According to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. So we will do it now, and we get that again cosine 90 degrees minus x is sinus x, so sinus x equals to 1 minus 1 over R squared. This is according to equation 2. While according to equation 1, we already found out that cosine x, according to equation 1, we already found out that cosine x equals to 1 minus 2 over R squared. So we have the values of sinus x and cosine x in terms of R. In the next step, we use the following trigonometric identity. That's actually states that sinus square x plus cosine square x equals to 1. And we have the values of sinus x and cosine x in terms of R. So we substitute sinus x in this trigonometric identity by 1 minus 1 over R squared. And we'll substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. So we'll do it now. So the new equation will be equation 3. So according to equation 3, we have sinus square x. So here we know that sinus x equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared squared. And also plus cosine square x. Cosine x equals to 1 minus 2 over r squared. If cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 over r squared squared. And it is equals to 1. Now if you find out that sinus x squared is equals to 1 minus 1 over r squared squared, that cosine square x is equals to 1 minus 2 over r squared squared, and all equals to 1. In the next step, we'll define 1 over r squared as t. Again, t equals to 1 over r squared according to our definition. And we'll substitute 1 over r squared in this equation 3 by t. We do it now and we get that here we have 1 minus 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t. And so in total, this expression will be equal to 1 minus t squared plus we have here 1 minus 2 over r squared. Here we can multiply this expression by 1. It is allowable to multiply anything by 1. When you multiply something by 1, some expression by 1, any expression by 1, it will not change the value of the expression. So here we have 1 minus 2, so it is minus 2 times 1 over r squared. 1 over r squared is t, therefore we substitute 1 over r squared by t. So in total this expression will be equal to 1 minus 2t squared. Okay, this expression equals to 1 minus 2t squared, and it equals to 1. So in conclusion, we found out that 1 minus t squared plus 1 minus 2t squared equals to 1. So here we will open the brackets on this side of this equation, equation 3. And we get that 1 minus t squared is equals to 1 squared, that is 1, plus t squared minus 2t. And we have also here 1 plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 1 times 2t is minus 4t, and it is equals to 1. So here we have 1 on both sides of the equation, so 1 will get cancelled. After we cancelled 1, what is left for this equation? So in this side of this equation 3 we have t squared plus 4t squared is 5t squared. And we have also minus 2t minus 4t is minus 6t. And we have also here plus 1. And it is equals to 0. Here we have 0. So in conclusion, we should find out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So actually, this is a quadratic equation. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. and we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say, 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. The only thing that we have to do is to put the data of our specific quadratic equation, this equation and this data inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. So we do it now, and we get that again x equals to t. So we substitute x by t. So t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a, so a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So in conclusion, we should find out that t equals to 6 plus minus. Inside the root we have 36 minus 20, 36 minus 20 is 16, so inside the root we left only with 16 divided by 10. So t equals to 6 plus minus, and the square root of 16 is 4 divided by 10. So here we will have two solutions that are possible for t. So copy this equation again in a new page. We shall find out that t equals to 6 plus minus 4 over 10. Repeat again. We actually found out that t equals to 6 plus minus 4 over 10. So here we will have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We'll do it now, and we get that 1 over r squared equals to 1. 1 over r squared equals to 1. So here we'll multiply this equation by r squared, and we get that r squared equals to 1. R squared equals to 1. So here we'll take a root out of this equation, and we get that r equals to the square root of 1, that is 1. So according to the first solution, for t the radius r of this circle equals to 1 unit in itself. But it is actually impossible that the radius of this circle r equals to 1. Why? Because of the fact that we know that chord BD or chord DB is equals to 2 units in itself, and chord DB is not the diameter of the circle. Again, chord DB is not the diameter of the circle. So now we know that it is given us the question that chord DB is equals to 2 units in itself. And from the drawing it is very easy to see that chord DB is definitely not the diameter of the circle. So write it down. Chord DB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. So the diameter of this circle is 2r. So 2r is the longest chord in the circle. This is the diameter that is the longest chord in the circle, and therefore 2r must be greater than dB, that is not the diameter of the circle. Again, 2r must be greater than dB, the chord dB, that is not the diameter of the circle. So and dB equals to 2. And from this equation, 2r is greater than dB, that is equals to 2. We will derive that 2r is greater than 2. Here we will divide this equation by 2. And finally we get that the radius r is greater than 1. So if we found out that the radius r of this circle is greater than 1 unit. If the radius r is greater than 1, the radius cannot be equal to 1. So the solution that the radius r is equal to 1 is the incorrect solution. We can send the solution, and we're left only with the second possibility for the value of t. According to the second solution for t, t will be equal to 6 minus 4 over 10. So I write it down. According to the second solution for t, t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t, t equals to 1/5 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. And therefore, we substitute t in this equation by 1 over r squared. We'll do it now, and we'll get that 1 over r squared equals to 1/5. So here we cross multiply this equation, and we get that r squared equals to 5. Here we take a root out of this equation, and we get that the radius r that we are looking for, the radius r is equals to either the square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. And that is the answer to the question. Repeat again. The radius r of this circle equals to either square root of 5 units in itself, or in terms of numbers, it is equals to 2.236 units. Okay, so in the next step, I will summarize the lecture. this lecture we found out the radius of this circle. So in the drawing we have a circle. Inside the circle we have chord dB. The length of chord dB is 2 units. We have also chord AC that is equal to the square root of 2 units in its length. And this is angle DEB. The size of this angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we join points A and D together by straight line. Again, we join points A and D together by straight line. We join points A and D together by straight line. Located there, peripheral angle DAB. This is peripheral angle DAB. And the size of this peripheral, we define the size of this peripheral angle DAB as x over 2. This peripheral angle DAB is subtended on chord DB. Again, peripheral angle DAB is subtended on chord DB. In the next step, we defined the center of this circle, this point as point O. We join points O and D together by straight line. We join points O and B together by straight line. By doing this construction, we can do center angle DOB. This is center angle DOB. And this center angle DOB is subtended on chord DB, exactly like this peripheral angle DAB that is also subtended on the same chord DB. So those two angles are both subtend on chord DB. So now we can implement here all 13. So I'll repeat quickly on all 13. According to all 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have also, this is peripheral angle ACB. This is peripheral angle ACB. The size of this peripheral angle ACB is theta. This peripheral angle ACB is subtended on chord AB. Likewise, we have also here central angle AOB. This is central angle AOB, and this central angle AOB is also subtended on the same chord AB. So those two angles are both subtended. They are both subtended on chord AB. And therefore, according to this rule 13, the size of this central angle must be twice as large as the size of this peripheral angle, because both of them are subtended on the same chord AB. And because of the fact that the size of peripheral angle ACB is theta, therefore, according to this rule 13, the size of this central angle AOB that is subtended on the same chord AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have those two angles that are both subtended on the same chord DB. And therefore, according to rule 13, the size of this central angle AOB must be twice as large as the size of this peripheral angle DAB, because of the fact that both those two angles are subtended on the same chord DB. And according to our definition, the size of this peripheral angle is x over 2. Therefore, the size of this central angle must be equal to x over 2 times 2, that is x. In the next step, we define the size of this peripheral angle ADC. This is peripheral angle ADC. We define the size of this peripheral angle ADC is y over 2. Okay, and this is this peripheral angle ADC is subtended on chord AC. In the next step, we join points O and A together by straight line, and we join points O and C together by straight line. When doing this construction, we get the central angle AOC. This is central angle AOC, and this central angle AOC is subtended on the same chord AC. So those two angles are both subtended on the same chord AC, and therefore, according to rule 13, the size of this central angle must be twice as large as the size of this peripheral angle, because both of them subtend on the same chord AC, and the size of this peripheral angle ADC is y over 2. Therefore, the size of this same triangle AOC must be equal to y over 2 times 2, that is y. Okay. In the next step, I presented to you rule 4, and we implemented rule 4 in our drawing. Actually, before that, I actually copied the right triangle DEB in a new page, and then implemented rule 4 in this in this green triangle DEA. So this is the green triangle DEA that is called from the original drawing. This is angle EDA. The size of angle EDA is y over 2 degrees, and this is angle EAD. The size of this angle EAD is x over 2. Those two angles and this angle also, they are all inside triangle EDA, and therefore they are all defined as the interior angles of this triangle EDA. While this is angle BED, this angle BAD is located outside triangle EDA, and therefore this angle is defined as an external angle of this triangle EDA. So now we can implement rule 4 in our drawing. So I presented to you rule 4 and implemented rule 4 in this triangle EDA. According to rule 4, the external angle of the triangle is equals to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles, A, B, and C, and all those three angles are defined as the interior angles of this triangle ABC because they are located inside the triangle, while this is angle E that is located outside this triangle, and this angle is defined as an external angle. So according to this rule 4, the size of this external angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C, this is interior angle that is adjacent to angle E. And the two other interior angles that are not adjacent to this angle E are A and B. And the sum of those two interior angles is A plus B. And therefore, according to this rule 4, the size of this external angle E equals to A plus B. That is the sum of the two interior angles that are not adjacent to it. Again, the size of this angle E is A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have here three interior angles, and this is angle BED, this is external angle. According to rule 4, the size of this external angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA that is adjacent to angle BED, and the two other interior angles that are not adjacent to it are those two angles, x over 2 and y over 2. And the sum of those two interior angles is x over 2 plus y over 2. And therefore, according to rule 4, the size of angle BED will be equal to x over 2 plus y over 2. Again, according to rule 4, the size of the external angle BED equals to the sum of the two interior angles that are not adjacent to it. That is to say, it is x over 2 plus y over 2. Okay? But it is given us the question that the size of angle BED, the external angle BED, is equal to 45 degrees. So we can substitute BED by 45 degrees, and 45 degrees equals to x over 2 plus y over 2. Here we multiplied this equation by 2, and finally found out that 45 degrees times 2 is 90 degrees, x over 2 times 2 is x, and y over 2 times 2 is y. So in conclusion, actually found out that 90 degrees equals to x plus y. Here we subtracted s from this equation, and finally found out that angle y equals to 90 degrees minus x. In the next step, I repeated quickly on the law of cosines, and we implemented the law of cosines in these two triangles, triangle AOC and this triangle DOB. So I repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. This is triangle ABC that could be any triangle. This triangle ABC, side, the length of side AB is A, Side AC equals to B within itself, and this is side BC is equals to C within itself. The size of this angle BAC is theta. According to this law, the law of cosines, the following equation is true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can actually implement the law of cosines in any triangle, and especially you can implement the law of cosines in this triangle, triangle BOD. So I copy triangle BOD in the new page, and we implemented the law of cosines in this triangle, triangle BOD. BO equals to OD equals to OC equals to OA, because all those 4 line segments are the radius of this circle, and the radius of this circle is R. So each of those 4 segments is equals to R because it is the radius of this circle. Okay, so actually this is triangle OBD that is coming from the original drawing. Side DB equals to 2 units in its length according to what is given as the equation. OD equals to OB, they are both the radius of the circle. Therefore, each of them is equals to R. R is the radius that we are looking for in this question. So according to the law of cosines, angle DOB equals to X. According to the law of cosines, in this angle DOB, cosine X equals to OD square. OD is R, therefore OD square is R square, plus OB square. OB is also R, therefore OB square is R square. So it is R square plus R square minus 2 times DB square. Minus DB square, not 2 times, but minus DB square. DB is 2, therefore DB square is 2 squared, that is 4, so it is minus 4. So in total, in the numerator of this expression, we have R square plus R square minus 4 divided by 2 times OD, that is R, times OB, that is also R. So it is 2 times R times R. So according to equation 1, we actually found out that cosine X equals to R square plus R square, that is 2R square. So in total, in the numerator of this expression, we have 2R square minus 4 divided by 2 times R times R. 2 times R times R is 2R square. So here we have 2R square over 2R square, that is 1. And also here minus 4 over 2R square. So here we divided both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R square over 2 is R square. So we actually found out that cosine X equals to 1 minus 2 over R square according to this equation, equation 1. In the next step, I copied this triangle AOC in a new page, and we implemented the law of cosines in this triangle, triangle AOC. So actually, this is triangle AOC that I copied from the original drawing. AO equals to OC equals to R, they are both the radius of the circle, that is equals to R. This is angle AOC that is equals to y degrees in size, and side AC equals to the square root of 2 units according to what is given as the equation. So in this triangle, triangle AOC, the following equation will be true according to the law of cosines. Cosine y equals to AO square. AO is R, therefore AO square is R square, plus CO square. CO is also R, therefore CO square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2, so it is minus 2. So in total, in the numerator of this expression, we have R square plus R square minus 2 over 2 times OA. OA is R times OC. OC is also R. So it is 2 times R times R. So cosine y equals to R square plus R square, that is 2R square, minus 2, divided by 2 times R times R, that is 2R square. So here we have cosine y equals to 2R square over 2R square, that is 1. And we have also here minus 2 over 2R square. Here we divided both the numerator and the denominator of this expression by 2, and found out actually that minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in total, actually found out that according to equation 2, cosine y equals to 1 minus 1 over R square. Okay, but we have already found out that y equals to 90 degrees minus x. Here, y equals to 90 degrees minus x. So now we can substitute y in this equation 2 by 90 degrees minus x. We did it, and got here that cosine y is cosine 90 degrees minus x. Again, cosine y is cosine 90 degrees minus x, and this equals to 1 minus 1 over r squared. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So now we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We did it and found out, okay? Again, cosine 90 degrees minus x is sinus x, and it is equals to 1 minus 1 over r squared. This is according to equation 2. Well, according to equation 1, we already found out that cosine x equals to 1 minus 2 over r squared. So we have here the values of sinus x and cosine x in terms of r. Now we use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. And we know that according to equation 2, sinus x equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared squared. And we have also plus cosine square x. We know that cosine x, according to equation 1, equals to 1 minus 2 over r squared. And therefore cosine square x will be equal to 1 minus 2 over r squared squared, and it is equals to 1. Okay, so if we found out that 1 minus 1 over r squared squared plus 1 minus 2 over r squared squared equals to 1, according to this trigonometric identity. Here we defined t is 1 over r squared, so t equals to 1 over r squared according to our definition. Now we can substitute t in this, we can substitute 1 over r squared in this equation 3 by t. We did it, and actually found out that according to this equation 3, 1 minus 1 over r squared. So 1 over r squared is t. So in total, this expression will be equal to 1 minus t squared. Here, 1 minus t squared. We have also plus 1 minus 2 times 2 over r squared. We multiply this expression by 1, and we found out that this equals to 1 minus 2 times 1 over r squared. So it is 1 and minus 2, and 1 over r squared is t. So in total, this expression will be equal to 1 minus 2t squared. Here, 1 minus 2t squared. And it is equals to 1. So actually found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. So here we open the brackets on this side of this equation, equation 3, and we found out that according to this equation, equation 3, 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, and we have also 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t equals to 1. Here we have 1 on both sides of the equation, so 1 we can cancel, after we cancel 1. In this side of the equation we left only with t squared plus 4t squared is 5t squared, and we have also minus 2t plus 4t is 160 plus 1 equals to 0. So we actually found out that t squared minus 60 plus 1 equals to 0. Actually, this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say 5t squared minus 60 plus 1 equals to 0, the variable that we are looking for is t. Again, the variable that we're looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. So x equals to t, so we substitute x by t, and we found out actually that t equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. A is 5, so minus 4 times 5 is minus 20, times c. c is 1, and minus 20 times 1 is minus 20. So in total we have 36 minus 20 divided by 2a. a is 5, therefore 2 times a is 2 times 5, that is 10. So if we found out that t equals to 6 plus minus, inside the root we have 36 minus 20. 36 minus 20 is 16 divided by 10. So t equals to 6 plus minus, the square root of 16 is 4 divided by 10. So here we have two solutions that are possible for t. And again, we found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t, t equals to 1 from one side. From the other side, according to our definition, t also equals to 1 over r squared. So we can substitute t in this equation by 1 over r squared. We did it, and actually found out that 1 over r squared equals to 1. Here we multiplied this equation by r squared, and finally found out that r squared equals to 1. Here we took a root out of this equation, and finally found out that r equals to the square root of 1, that is 1. So according to the first solution, the radius r of this circle equals to 1. But it is actually impossible that the radius of this circle is equals to 1. Why? Because of the fact that it is given us a question that the length of chord dB is 2. Chord dB equals to 2 units in its length, and from the domain it is very clear that dB is not the diameter of the circle. Again, dB is not the diameter of the circle. Again, we know that chord dB equals to 2 units in its length, and from the domain it is very clear that chord dB is not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord of the circle. The diameter of this circle is of course 2r. So the diameter 2r is the longest chord in the circle. Again, the diameter of 2r is the longest chord in the circle. And therefore it must be greater than dB, that is not the diameter of the circle. Again, the diameter 2r must be greater than dB, that is not the diameter of the circle. And dB equals to 2. And from this equation 2r is greater than dB, that equals to 2, we will derive that 2r is greater than 2. We will divide this inequality by 2, and finally we get that the radius r is greater than 1. So the radius r of this circle is greater than 1. If the radius is greater than 1, the radius cannot be equal to 1. So this solution is the correct solution. We cancel this solution, and we'll take into account only the second solution for t. The second solution for t is t equals to 6 minus 4 over 10. Again, t equals to 6 minus 4 over 10. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t, t equals to 1/5 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1/5. Here, of course, multiplied this equation, and finally found out that r squared equals to 5. We took a root out of this equation, and finally found out that the radius r, the radius that we are looking for in this question, the radius r equals to the square root of 5 units in its length. Or to have some numbers, the radius r of this circle is equals to 2.236 units. Okay, thank you very much.